So I'll start with a quick recap of the previous session, then I can go through the quiz. If you haven't yet done the quiz, that's okay. We can kind of go through it together. And after that, I'll pause to see if there's any particular questions, either related to the quiz or the content or any of the examples. And if there are no particular questions, I've also prepared a sort of second example, a very simple one, just to illustrate some of these functions. We can go through that. But feel free to stop me at any point along the way. This is a very open session. So let me provide a quick recap of last week's session. Okie doke. You will be seeing this quick little Word document on my screen here. So for those who weren't here last time, what we were focusing on was a particular package called tidyr. Now tidyr relies on this concept of having tidy data. And tidy data is just a way of organizing data. So organizing your data sets that just enables analysis, visualization, and manipulation. So it just makes all of those things easier. And the idea behind a tidy data set is each column is a single variable, each row is a single observation or a patient, and each cell is a single value. This all seems pretty intuitive, pretty common, but we often have data sets where, for example, you'll have different columns for different years of data. So you have, I don't know, height and weight in 2013, 2014, 2015. So all of those columns then are no longer single, they're not distinct, they're all representing years. So tidy data basically makes it easier to restructure data so that it can work well with tidyverse packages in R. But this is not unique to R, actually. If you ever learn a different programming language, almost every programming language has some concept like this, where there is a standardized data structure that makes things easier to work with. Tidy data happens to be the one that works with R, but this notion is quite common in data science in general. So as I mentioned, the package that's useful for tidying data is called tidyr, which is a package within the tidyverse. Tidyr itself allows for things like reshaping data, manipulating columns, exploring data, and handling missing values. It has advantages. For example, it makes it easier to add new variables as columns, or new observations as rows if you have tidy data. Tidy data also allows functions to operate effectively on all data sets that are structured. It just means things are more uniform, reduces the likelihood of errors. Tidy data also makes it easier to visualize data. This is because if you remember from a couple of sessions ago, we were talking about ggplot, and something that's quite inherent to ggplot is this idea of mapping. So you take a data set and you map some variable to the x-axis, you map some variable to the y-axis, you map some variable to different colors on your graph. And that mapping becomes a lot easier when you have tidy data, because one of the things that's inherent to tidy data is each column is a single variable. So if you have each column in a single variable, those columns suddenly become easier to map directly. Again, we'll see this more in examples in the quiz and such, but I encourage people to read more on this if you are at all curious. The last thing we talked about before going into more practical functions was about tibbles. So tidy data is often stored in a data structure called Tibble. So tibbles are like data frames, but a little bit more advanced. For example, they allow you to have blank spaces and numbers as variable names. When you print a data frame, it often prints the entire data frame, but tibbles only print the first 10 rows. Indexing is a bit more strict. Indexing just means when you're pulling out columns, so you have to basically name that column exactly to pull it out. There are functions to create new tibbles or change data frames into tibbles. Tibbles also do something called preserving variable types. So for example, sometimes data frames will automatically convert character columns to factors, but tibbles never do that. So that's just a bit of theory, just to reiterate some of the things we learned last week. Then we kind of went in and looked at different functions within tidyr. Now, these are by no means all of the functions. tidyr is actually quite extensive, but I tried to pull ones that will be more relevant to you. There are more advanced functions like nested data frames and such, but I mean, I've never used those in my experience. I don't think they're as commonly used in health research, but if you're at all curious, that's something you can look into. So this table here just recaps each function, what it does, which I think will be illustrated better in examples, and just an example scenario where it's useful. So pivot longer is actually used quite often to go from wide format, so many columns, to fewer columns. This is often the workhorse function if you're actually tidying data. So you can often think of tidy data as a long format of a data. This basically gathers multiple columns and gathers them into something called key value pairs. This is illustrated here. For example, if you have a survey data where each column is a year, so 2019, 2020, 2021, using pivot longer to create, you can create a year column and a value column. So the year column will have values like 2019, 20, and 21. The value column will have whatever value that survey is measuring. Similarly, you can go backwards. You can use pivot wider. This converts long data into wide format by spreading these value pairs into new columns. So for example, if you have sales data with columns called region, product, and sales, you can use pivot wider to make each product a separate column, for example, even each region a separate column, and compare across regions or products. So basically allows you to split up your data set like that. There's also separate longer, which we saw, which takes a column with delimited text. So for example, it has multiple values within a cell. And you can split that up into multiple rows. So for example, if you have a column with skills called R, Python, SQL, you can use separate longer delim to split these into 3 rows, one for R, one for Python, and one for SQL. This is handy for visualization and for summarizing data sets because it allows you to separate. Remember, and one of the ideas behind tidy data is that a cell contains a single value. So over here, this would be one cell containing 3 values. In an attempt to tidy it, we would be separating that into 3 rows instead. Alternatively, you can separate into columns instead of rows, which is separate wider. This is very handy actually in electronic health records because often you have things stored in one column, like blood pressure. In this particular example, they're showing a full name that's being separated into 2 columns called last name and first name. Similarly, you can unite multiple columns. This just basically does the opposite of separate wider delim. So if you have a first name and last name column, you can use unite to create a single full name column. The next couple of functions we saw explored combinations of values for specified variables. For example, expand shows it can create a grid of all possible combinations of whatever values you choose. So in this example, they're saying year and region. So it'll generate all possible combinations. And then you can compare it to your data set to see which ones are missing from your data set. Complete does the exact same thing, but takes it one step further, where it'll add NA for missing values. So if you have monthly sales data, but some months are missing, you can use complete to ensure all months appear and then fill in missing months with NA. So this will it'll show you all possible combinations. And for ones that don't exist in your data set, it'll just add a blank row. And there were ways to 3 different ways we saw to deal with missing values. There's one example called drop NA, which removed an entire row based on a missing value. So for example, you have a data set with some incomplete records. You use drop NA to remove entire rows where sales data is missing, for example. You can also fill in missing values with this fill function. This by default replaces a missing value with the most recent value. You can choose to do it above or below. So by default, it does it the most recent value above. This is quite useful in scenarios with time series data. So for example, if you have a data set with many months of data, but you're kind of only the first month has January, February written in, you can fill in the blanks with the previous rows. And finally, we saw replace NA, which is where you're replacing blank values with a pre-specified value. So over here, for example, they're replacing blanks in the column discount with 0 instead. And this is quite useful as well if you're creating a table and you want to replace blanks with the word unknown, for example, or if you want to replace it with a mean or a median of that column if it's a continuous variable. So that was pretty quick. I just wanted to recap what we learned last time. Our colleague Athumani has posted this on Afredac's website as well. So you can check out all the content from last time. It isn't actually a lot of content. This is one of the shorter sessions because tidyr is but one package. But what's key to this session, I think, is just practicing. So I'll pause there to see if there's any immediate questions. If not, we can move on to the quiz and go over the quiz. No immediate sessions. I will open up the quiz. What I'll do is I'll share my screen and share the questions on the document, and I'll ask people to put their answers. You can either unmute and answer or put it in the chat. There we go. This is the quiz. For those of you who haven't done it yet, we can do it live together. But this is just to show you what the quiz is like. So online, it's you're able to access it as well. But we can go through each question together. And if you have any particular questions about any of these, we can also answer them. So I'll be looking for your answers either in the chat or unmuting and answering. So the first question asks, what is true about tidy data? So option A suggests tidy data means that each row has multiple observations. Tidy data means that each column has multiple observations. Tidy data means that each row has a single observation, or tidy data means that each cell has a unique variable. So which of these options do you think is true? We'll wait and see if anyone puts it in the chat. Either Vivi, Frank, Damilola, Henry, Mercy. Is that C? Correct. Frank is correct. So tidy data means that each row is a single observation. Perfect. Next, what is one way that, hold on, let me minimize the chat. What is one way that a Tibble is different from a data frame? So the options are: a Tibble has stricter indexing, a Tibble's indexing isn't as strict, a Tibble will print out in its entirety, whereas a data frame won't, a Tibble won't allow for numbers in variable names. So which of these is true? Again, you can either unmute or put it in the chat. See who else is here. people don't put answers, I will start picking on you. Perhaps I can see if Vivi knows the answer. Oh, I think Frank got the answer. Would you put 2A correct? This is the correct answer. Tibble has stricter indexing than data frames. The next one's a bit long. Let me see if I can, actually, yeah, you should be able to see all of it. Okay, so over here, this one, suppose, oh, okay. Suppose I have a data set called data clean, which I would like to change to long format. I'd like to change data clean's column names to go under a variable called sex, and I'd like data clean's cell values to go under a variable called height. Nothing should happen to the PTID variable. How would I achieve this? So names to sex and values to height, but nothing should happen to PTID. And I would like to change it to long format. So which of these options works best for that? So perhaps someone other than Frank this time. Let's see if others remember. Okay, in that case, I can share with you the answer for this one. But I'll just want to check, is everyone clear on how to read this code? If there's any ambiguity in how to read the code, what it means, do let me know, and then we can explain how to get at the right answer as well. So this one, the trick to figuring this one out is that this code is often read like a sentence as well. So we know from the question that we'd like column names to be under a variable called sex and values to go under a variable called height. So immediately I'll be looking for names to sex and values to height. Another thing I noticed in the question is that I would like to change this to long format. So I know it can't be the first one because the first option is asking me to pivot wider. So I'll look at these three, pivot longer. And I want names to sex and values to height. So it's got to be between these two options, between B and C. And the trick to figuring out whether it's B or C is to look at this line here. So we want nothing to happen to the PTID variable. So for here, in R, the exclamation mark is a negative operator. So if you put exclamation mark, it means, nothing should happen to that variable. So the one of these two that has the exclamation mark is B. So exclamation mark PTID means nothing should happen to PTID. And this would be the answer to this question. So hopefully that makes sense. The next one is quite similar. I'll see if folks are able to figure this one out. So over here, we're doing the opposite thing. We're saying, suppose that I have a data set called data clean wide. I'd like to change this to long format, drawing column names from the variable called sex and cell values from the variable called height. Once again, I don't want anything to happen to the PTID variable. Oh wait, I think my English in this one got a little bit confused. I would like to change this one to wide format, I believe I meant to say. This might have been my draft. This might be my draft question set. So over here, yeah, so suppose I have a data set actually called data clean long that I'm turning into a wider data set. So over here, I'm drawing names from the variable sex and values from the variable height, and nothing should happen to PTID. So over here, the first trick is looking for pivot wider, because I'd like to change to wide format. So it's either between A or D. And I'm drawing the names from sex and values from height. I'm realizing A and D might actually be the same option. Let's hop over to the next question. This is just strange. This might be an older version of the quiz. Okay, but A and D are the same. That is the answer then if you're going from wide or longer to wider. Okay, we got some easier questions here. We have one saying I can split a column into two only if there's a forward slash that appears in the entries of the column that I'd like to split. True or false? So between Vivi, Frank, and Damilola, does anyone know the answer to this one? This one's claiming that you can only split if there's a forward slash that appears in the column. It's saying you cannot split a cell if there's more or any other operator in there. I mean, I just don't know it's my first class today. Oh, no worries. Thank you for joining. I can explain a little bit what's going on here then. So this is basically the quiz for the previous session, which is also recorded. So you're welcome to watch the previous session and kind of go through the content as well. But over here, perhaps then I can, for the rest of the quiz, I can explain a little bit more about what's going on. But welcome. Thank you for joining us. So over here, this is looking at a function that basically, so for example, in a lot of health data sets, as we mentioned before, you often have data on something like blood pressure or things that inherently have two items in the measurement, right? So you have systolic and diastolic blood pressure. But sometimes in order to work with that data, we want to split it into two columns or two rows. A common misconception is that you can only split if there's a slash over here, but actually you can split a cell that has anything in the middle. So if it has a slash, has a column, or colon, semicolon, comma, you're able to kind of use a function within tidyr to split that into multiple columns or multiple rows. And the following question kind of illustrates that. So it says, explain what the following code is doing. So over here, the way you would read this is that we're taking the data clean data set. Now we're separating wider. So we're creating more columns. So we're going to use the column blood pressure over here. We're going to take a column called blood pressure. We're going to look for a forward slash. And before and after that forward slash, we will separate it into two columns. And these two columns' name is BP systolic and BP diastolic. So in this thing, this is basically splitting the blood pressure column into two columns. Splitting the blood pressure column from the data set into two columns named BP systolic and BP diastolic. The split occurs where the character forward slash appears. That's what that code is doing. The next question over here says, suppose I have a data set with the column health facility type, and under health facility type, I have values primary, secondary, and column health facility size with entries small, large, small. How many total unique combinations of health facility type and size are there, whether or not they actually appear in the data itself? So over here, basically we have two different types of health facilities, right? Primary and secondary, and two different types of size, small and large. So you can have 4 combinations in total. So you can have primary small, primary versus large size, secondary small, and secondary large. Now, some of these we see don't appear in our data set, right? So for example, primary small appears, primary large appears, secondary small appears, but secondary large does not exist in our data set. The next question here asks, how would I drop all rows with missing values from a data set called data clean? Now, if you remember, there were 3 different functions that we learned about. There are many, many more, but among the ones we learned, there were 3 functions that dealt with missing values. And one of them, called drop NA, removed all rows that had any missing values. So you can sometimes only drop some rows or drop specific missing values, replace certain missing values, but this drop NA drops all rows with missing values. Similarly, you can choose to replace missing values. For example, if you have a data set called data clean, this question asks if you would like to replace all missing values for the variable age group with the word unknown, how would you accomplish this? So the function used to accomplish this is replace NA. So we already know it can't be this answer. Replace NA uses this list operator. Basically, this allows you to replace multiple variables if you want. But if you want to just replace a single variable, you can say age group equals unknown. So this over here would allow you to replace all missing values under age group with the word unknown. Over here, and the last question is asking, one should always replace missing values in a data set with the previous value. Now, this isn't always true, actually. There are functions that automatically do this, right? So the fill function will automatically, if you don't specify otherwise, it'll fill missing values in a data set with the previously non-missing value. But this isn't always a good practice. This only makes sense in certain situations. For most situations, it wouldn't make sense. So this is where kind of your own intuition as a researcher or as a clinician comes into play, right? Because context is also very, very important with the data. So that's a quick look at the quiz. If you haven't yet tried it out or seen the material from last time, you can access the material, the course notes, all of this online. You can try out the quiz on your end, and you can post online if you have any follow-up questions. What I'll do is I'll pause there actually. I'll see if you have any specific questions from either the quiz or the examples or last week's content. If there are no questions, I'm happy to go through an additional example with you to just reiterate some of the concepts from this module. What I'll do now then is this is just a short example. Let me increase the size so you can see better. Hopefully that's big enough. If it's not, let me know. So this is an example kind of unrelated to the HIV example, which we went through during the actual session. This example is very, very simple, actually. It just shows kind of each of the functions that we saw. It just shows how they might be applied in a certain situation. So I'll go through this, and if there's any questions as we go along, do let me know, and we can answer your questions. But beginning of this, like any other code, I am loading my package here. I've just loaded all of tidyverse. Technically, I only need tidyr, but for good practice, I'll just load all of tidyverse. I'm also anchoring, I need to open the project associated with the file. oops, this one I have to rename it so that it is the same as additional examples. Let me close this and reopen it. Give me one moment. I think I got confused because I was working on something else alongside. Let me just reopen it. Right. Okay. Tidyverse. Okay, now I've anchored my code. Here we're using a totally fictional example data set that, truth be told, ChatGPT produced this example data set. It does not exist in real life. So it's a Tibble over here because we're working with Tibbles. These are all the different columns. So you can see this Tibble function allows us to create the Tibble. This is how we go about naming columns. There's an ID column, a name column, year 2020, year 2021 with some values. Skills, full name, month, and sales. This is what the whole thing looks like. If I click on DF, this is what the example data set looks like. It's a very, very simple data set. Only three people are in it. Over here. This is what we're going to be working with. All right. So first example we'll see is pivot longer. So this column or this data set we've called DF. We're going to use the pivot longer function to take any columns that start with year over here. We're going to change them. We're going to add them to a single column called year. So if you remember, there's year underscore 2020 and year underscore 2021. What this function will do is any column that starts with year underscore, so those two columns, it'll add their names, their column names, it'll add them under a variable called year, and it'll add their values to a variable called score. So now we're supposed to have, df long should have 6 observations. So over here, so now we have got a year saying year 2020, 2021, and the score is those values. So let me compare it again to show you how it compares to this. So over here, the values were 10, 20, 30 for 2020. And for 2021, the values were 15, blank, 35. So now those kind of are squished into one. So we have year 2020, the values for 2020 are 10, 20, 30. The values for 2025 are 15, blank, and 35. Does everyone understand how that happened? Do jump in if there's any questions. Okay. So similarly, we can now go back from long to wide if we want. Over here, suppose we want to draw the names from here and values from score. What this will do is it'll create as many columns as exist under year. So if there are 3 different values under year, it would create 3 different columns. In our case, we only have 2 different values under year. We have year 2020 and year 2021. So it'll create 2 columns. It'll draw the values for those columns from score. So if I run this, our df wide should once again look like df. So we've gone back to 2 columns. Now separate longer delim. Over here, if you remember, the skills column over here had multiple values inside. So we have R Python SQL, R SQL Python. Separate longer delim will basically separate each of these based on the comma. It should separate these into multiple rows. So once again, doing this, we should have 6 rows over here. DF skills. Now, if we compare it to DF, skills were kind of squished like this. Now we've got each skill is its own row. And you can notice, for example, because Alice over here had 2 skills, R and Python, now Alice occupies 2 rows here. And for all other variables, it's just repeated whatever value she had over there. So I'll show you once more. It's gone from Alice in one row over here. And here there's Alice in 2 rows. Similarly, we can choose to use the separate wider delim function. So over here, the example it's showing it with is with the full name column. It's now again saying we should separate it based on the comma delimiter. Delimiter is the comma. And we want to separate it into columns called last and first. So when we run this, df names, this is again still only 3 rows because we've separated into multiple columns instead of multiple rows. So in df, you'll see there's a column called full name, Smith, comma Alice, Jones, comma Bob, and Brown, comma Charlie, which is now separated into last first. So let's split these names into last first. And I can add these together as well. If I wanted to string this along, I could also string this onto this data set, and df names would now be, now we have 6 rows because now we've separated skills and names. This is a part of the process of tidying data. Similarly, now we can unite names. So suppose we want to bring that first and last back into full name. So over here we're saying unite, create a variable called full underscore name. It should draw from the first and last variables. And the separation should now be a space instead of a comma. So df united has now gone to Alice Smith. So you can see, so it grew from the first name and the last name and united them into a single column called full name. Now the next couple of functions show us how to work with combinations in our data set. So for example, I can use something called expand underscore grid. Let me show you how this works. Expand underscore grid. So basically this is now showing you all possible combinations of ID and month. So let's say months are Jan, Feb, and March, and your ID is 1 and 2 over here. So this will basically show you all possible combinations of IDs 1 and 2, and then Jan, Feb, March. So it should have 6 rows because, yeah, so you can have a combination of 1 Jan, 1 Feb, 1 March, 2 March, 2 Jan, 2 Feb over here. So it just shows you what possible combinations can exist. Complete, on the other hand, will use our data set. We'll show you what possible combinations exist for ID and month, but it'll add a blank row where those combinations don't exist. So if I run this, the df complete. So here I was looking at ID and month. Remember there was 1, 2, here we have 3 IDs. So there's no one with ID 1 from February. So this is just inserted blanks over here for all other columns. Similarly, there's no one in our data set with ID 1 from March because Alice had ID 1 and she was had logged this in January. So it is introduced in NA. And similarly for the other rows, it is just introduced blank rows where that combination of ID and month don't exist in our data set. And finally, last 2 examples show how to deal with missing values. So if you go back to our original data set, DF, there are some missing values, right? So there's a missing value under year 2021 over here, and then under sales there's a missing value. Now suppose we wanted to drop all rows that had a blank under sales. So if we wanted to drop all rows that had blanks altogether, we would simply use drop NA. But if we wanted to focus on a particular variable, suppose sales, and only drop rows with blanks in sales, we can use this, drop NA and then sales. So df drop would now only include observations for which there are complete values for sales. Similarly, suppose I have a data set with the months Jan, Feb, March, and April here. Let me just show you what this data set looks like in isolation. Suppose I have a data set that looks like this. Month and sales. And there's two blanks over here. So both February and March have blanks in the sales. Suppose I wanted to use the fill function, and I wanted to fill in blanks in sales. I could do it this way. And now df fill will fill any blank values with the previously available non-blank value. So over here, by default, it fills in the downward direction. Here we have specified direction equals down. If I were to remove that, it should work the exact same way. So it'll fill it with 100 because 100 is the previously available value. I can switch this to up. And now it'll fill upwards. So it'll fill February and March with 200 instead. But by default, it fills downwards. Lastly, we can also replace blanks. So in our original data set, if you remember here, we had a blank under year 2021, and we had a blank under sales. I can, for example, fill these blanks in with the value 0 using replace NA. This is now filled this in with the value 0. Or I can choose to replace it with something else. I can say unknown. Oh, it won't. Yes, it won't replace it with a character. So I have to replace it with a number because that's a number over here. So now we replaced it with 999, for example. You can really replace it with anything. If I wanted to replace it with unknown, I'd have to convert it to a character first. Let's say mutate sales equals as character sales. And then we can replace it with the word unknown. Ooh. Now you'd be able to replace it with unknown. But it would be important to convert it to a character first. Because if it's a number, it'll only accept replacements that are other numbers. Those are some quick examples, very simple ones, just to show how each of these functions works in practice. If you're looking to practice on your own, I would recommend trying it with that HIV data set that we saw last time, because that, there's more to play with there. This one was a rather simple data set just to illustrate some of the examples to reiterate how to apply them, especially for those who may have not been here last session. So let me pause there and see if there's any questions.
Ashna.
Yes.
I have a question. I've seen that what is the difference between expand grid and expand?
Yes. So I think expand grid, expand requires you specifying a data set, whereas expand grid doesn't. So I think, for example, here, I don't think I specified a data set for expand grid here. Or at least that's what I understand. Next, over here, we're not specifying data set, whereas if I did expand or df, expand ID months. This would require us to specify the data set.
I see.
So here, this has included all the possible combinations in our data set. Over here, actually, let me see if it works if I just say expand. Yeah, no. So here I haven't specified a data set.
Okay.
I've just specified, I guess, random variables here.
Okay. So it's like when you're calling the expand grid, it's just working for the arguments that you're giving, which will eventually define the data set.
Exactly.
Okay. Then thank you for that. And my other question is, if we scroll up, I wanted us to try something just for
Yes.
For argument's sake. Let's go up again. There. Pivot. I can see when you're calling the pivot longer, the variable of names too is a string and is actually defined so.
Mhm.
Could you also try to do that number that 9 and see whether it works?
Oh, over here, instead of year, just putting a
Yeah.
number.
No. I would like us line 39. You see the way the E is
Ah,
written.
39.
If
Yes.
if if you can encapsulate it with the quotation marks, we see whether it runs.
Ah, yes, that's good.
Uh,
Oh, it ran.
and the score?
And the score, let's see. Aha, let's see if it did it correctly.
Uh, okay.
Oh yeah, it still ran. Okay.
Ah, wonderful. Because that's something actually I've never understood with R because
Yeah.
there are some instances that you fail putting those quotation marks and it doesn't work.
Yes. Strange.
And
Because
it
I
asks,
guess it recognizes them as variables also, but for some
yeah.
it works with the quotation marks. That is very strange.
Okay. Thanks so much, Ashna.
No, thank you. Now I've learned something new too. Do any others have questions or things they wanted to see? So maybe I can ask the crowd a general question. For most, have most seen the content? I know Damilola, you said you haven't yet seen the course content. But for others, have you been to previous sessions? We have other facilitators on the call as well. If there's any questions from previous sessions too, you're welcome to ask because a lot of these kind of build on each other. You may have noticed that tidyr builds on the previous sessions too. And yes, absolutely. Damila, if you have questions while you practice, feel free to post on the online forums and stuff. And these RFC, R for Fun sessions happen every other week anyways, and you're welcome to bring questions to a future session too.
Ashna, sorry, I have a
Sure.
question.
Yes.
Um, if it's possible to go back to the codes again,
Yes.
on the part of fill function.
This one.
Yes, yes. What what guide us to decide either to use the upper value to fill or the mean value or the below value to fill the missing values?
That's a good question. I think it's entirely context dependent. So situations where I've used fill for the upper value have mostly been time series data. So for example, I had a data set that looked like, let's just say, Jan. So I had a data set that looked something like this, where I had values, but only the first row was filled in for the month. But I knew that all of these also came from January. So in this case, I had basically said fill month. And the default is just filling it from the upper direction. So I said kind of in the case that I had, you should fill in, oh, interesting. That did not fill month. Oh, it's because this does not recognize this is a blank. Hold on. And there we go. So basically it had filled it in with January. So it would make sense in that context. If you know already that, this value 300 and this value 100 is from January, indeed, you could fill it in with the value above. Other times when it might be useful to fill from below, I can't think of one off the top of my head. But again, it is contextual. It might be a similar situation where these are actually February values, so then you fill in February for the month. In terms of filling in missing values with means or medians, that, as far as I know, is only recommended if you have a few missing values. For example, if you had a data set with, let's say, 100 patients and 5 or 6 patients were missing a value for their age or weight, and filling those values in with the average age or the average weight for the cohort could make sense because there's not that much missingness. But there's no hard or fast rule for what counts as few values missing. That's kind of up to the researcher to decide. If you want to err on the side of caution, you'd kind of leave everything as is and wouldn't replace anything. But if there's few enough missing values, it makes sense to replace in a way that would not skew your entire data set. I have seen it used in those situations. Hopefully that answers your question.
Yeah, thank you.
I see in the chat how to impute in R. So imputation's kind of an umbrella term for all of this. So anything where you're kind of filling in missing values with other values, that is all imputation. So fill is one of the ways to impute with the previous value, but the most kind of common idea of imputation is this, when you replace values with an average or a median. So over here, if I had replaced year 2021, if I instead replaced it with mean, let me just turn this into another row so it's easier to see. Mean of DF year 2021, nor blanks. Over here, DF replace. Over here, it's replaced the missing value with 25. So remember there's a missing value over here. And then the average of 15 and 35 is 25. So that's what it has replaced with over here. So that is one example of imputation. Imputation gets very, very fancy also. Depending on how much data is missing, there are pretty complicated methods for replacing blank values. So there's ones that even involve machine learning and AI to figure out what the best ways of replacing blank values are. But this is perhaps the simplest way to impute in R. So you can use the replace NA function. Hopefully that answers that question.
Also, Ashna,
Yes.
I have a data set here. I can show so that it can provide a context as to how one can actually impute.
Sure.
Let me share it.
Sure.
Just 10 seconds. I show you.
Sounds good.
Yeah. So this one is a data set when people are drilling for geothermal energy, so that they can actually get the steam to generate power. First of all, what they do, they normally drill what is called the appraisal wells, so that they can actually be able to map the nature of the steam reservoir that is there. So what they do, like what you see here in column A, this is actually at the depth of the drilling in meters. Then in column B, for example, this is just well 1, and what corresponds is the temperature in degrees. So you can see as they go deeper, the temperature increases. So when it comes to a place like 450 meters, you can see it's the value there is about 55.2 degrees, and at 460 meters is about 56.8 degrees. So there's no way at 450 I can fill with a lesser value than 55 or 56. I just have to find a way. Either I fill forward with the 55.2, which may introduce a bit of error, or I can just interpolate between the two and get the missing value. Whether I can do the average of at 450 meters, 440 meters, and 460 meters, and at least impute with the value of the average between 56 point, an average of the values 56.8 degrees and 55.2, so that I can get the average. And you can see also as you go deeper at 550, the value of the temperature is also missing. So I support what you're saying, Ashna, is that sometimes it just depends on the context, and fill in with plausible values for that missing data. So this is just one of the practical examples as to how one may resort to actually filling some of the missing values in a given data set in a way at the end of the day that the filled values will also make sense.
Awesome, thank you. Yeah, this is a really good example. I guess time series data is where it could make sense to fill in blank values. Yeah. Thank you, thank you. Yeah, it's all very, I know there's no clear answer, and I wish there was sometimes clear answer, but it's all context dependent, I guess, with data. I see it says, Frank says, is it allowed to impute both independent and dependent variables? I think more dependent you would impute. Independent, I'm trying to think. I guess independent would be more difficult to impute, because if you only have measurements for certain time periods and time is your independent variable, if there are periods of time where you have not taken a measurement, then those rows just would not exist.
Mm-hmm.
But yeah, for dependent, you can certainly impute. But all this becomes very handy dealing with real data, and especially for anyone who deals with medical records. It's quite rare to have complete data, so your data set is quite likely to have missing values. Are there any other questions, queries, concerns? If not, we can encourage folks to post anything online as you're doing your examples, or at future RFC sessions. If you have particular questions, you're welcome to come with, and we can help you resolve any issues. Even if you're trying to work with your own data and are trying to apply any of the things that you have learned here with your own data set, we're happy to kind of help you, so support you in that as well. Okay, I think we're all set then for this one.
Okay. Thank you so much, Ashna, for that interesting review, for that very good illustration in that example. So I think in case you have any questions, and as Ashna said, it's not a must that you practice the data set that we have. You can come with your own data set. Then you can also try to apply the techniques that we have learned those data sets, and at least try to make you have a feel of what we're actually doing. So thank you so much for attending today's session. And maybe for Damilola, who said it's the first time today, maybe let me share something on my screen. So far we have already done we are on 11th of September. That is week 6. Today was Art for Fun Club. The previous sessions, like the refresher on the R workflow and structure, data cleaning with the dplyr, tidy data, and the data wrangling with tidyr. All these are on our platform. You can always visit there. All the questions are there. You can try them during your free time. In case you have any question, please post it on the platform. We'll get back to you. And next session will be just a review on the data visualization using ggplot2. We already covered most of the concepts in the previous training. So next week, we'll just do a review of that. Then come October 2nd, we'll just now look at some of the advanced techniques that can be used in visualization in R. So so far so good. I think we are progressing well. You can pass the message to your colleagues that they can get all the content on the platform. They can visit the content and get on the platform, and also tell them of the future sessions that we'll be having. Otherwise, Ashna will come back again on session 7, where she will show us time series visualization for health trends. So be sure to get that. So we meet next week for a review of the data visualization using ggplot2. In case of any questions, please, you can always reach out to any of us, and we'll get back to you. Otherwise, I wish you a good day, a good evening, and see you all next week. Thank you.
Thank you. See you next week.